Thanks again very much, Mr. Fordes, for providing an excellent contribution to this conference for political science. It's much appreciated. Thank you. If you look at your watch, would you please adjust your watch to local Cyprus gaming time? It's 9:50 now. Please make sure you've got the right time. And we continue following the schedule, maybe a little bit shifted, but I make sure we keep on track. And for the next 20 minutes, we have a combination of natural intelligence and artificial intelligence. Please welcome Dr. Panagiotis Kouvaros, Assistant Professor of Artificial Intelligence with the University of Limassol in Cyprus, talking about artificial intelligence, the science, the benefits, and the risk. What a wonderful and very timely topic, and how important this advanced development will be. I'm keen to learn what you have to tell us. Please join me. And you make sure, if you have any questions later, use the Slido app and send it to us. Thank you.
Good morning, ladies and gentlemen. Let me start by giving my special thanks to Ioanna Fiakou and the National Betting Authority for the invitation. I'm truly honored and humbled to be here. So today I will talk about artificial intelligence. This is now a technology that has entered the public consciousness like no other technology did in decades. It enabled for the first time machines to have human capabilities. It was used to beat the champion at Go, a strategy game that is far more complex than chess. It was used to solve the protein 14 problem, a scientific problem that was researched for decades. And it was used to create tools like ChatGPT, with which most of you are most probably familiar with. So it is easy to get excited about the potential of the technology, but also to be apprehensive because of the kind of challenges of what it means to be human. And because the unknown leads to extremes, where these extremes are overexcitement or fear, today I will talk about the science driving modern AI. And therefore, hopefully, you will be able to reason yourselves about the benefits and about the risks of AI. So how do we build artificial intelligence? Well, we already have an intelligent machine, which is our brain, so we could try to imitate that. And a crucial aspect of what makes us intelligent is the concept of learning. So learning is absolutely essential to intelligence. We all go through a process of learning, starting from the alphabet, before we can read the great novels of the world. So how learning works? The way it works is very simple. We have data coming in through our senses, and this data becomes signals that go through a network of neurons. And depending on what is happening in the world, the synapses connecting these neurons in the brain either get stronger or weaker. So at a very high level, this is all that is going on. Now, an artificial neuron, which is the basic building block of modern artificial intelligence, works in the same way. So it tries to mimic a biological brain. It starts with getting various inputs. It does some processing on these inputs, and then it produces an output. Now, how does artificial learning work? How do these artificial neurons are able to solve complex tasks that modern artificial intelligence is doing? The best way to think about it is to think about a neuron as a tuner, where it is tuned to previous experience. So let's see an example. I chose an example with which all of you can relate to. So assume that we want to build an AI model that predicts whether or not we will enjoy a certain restaurant experience. And for the sake of the example, assume that this depends only on how expensive the restaurant is and on the length of the menu. So let's build an AI model that makes this prediction. We start with initializing the tuner at a random position, okay? And we have two inputs for the model. One is the expensiveness of the restaurant, and the other is the length of the menu. Then we feed it previous experience. So assume we have, so the ease there should be dollars. So assume we have a case of a previous experience for a very, very expensive restaurant. So we feed this case into the network, and the model outputs yes. Now we know that this is not true because maybe we could not afford the prices of the restaurant, so it was not a good experience for us. So what we do is that we tune the model so that it outputs no instead. Now we feed it another experience. So this is an experience with a reasonably priced restaurant, but one which has a lot of dishes. So we feed this input into the model. The model outputs yes again. But again, we know that this is not true because, say, that the ingredients that we are used to make up the dishes were not fresh. So this was not a good experience. So we further adjust the tuner so that it outputs no. And we do this for all data, previous experiences that we have, and then we obtain an artificial intelligence model. Then we can use this model to make predictions about new restaurants, right? We simply feed the information of the restaurant into the model, and then we get a prediction. So this is at the very high level how artificial intelligence works. And to further demystify this tuner, what we have is that this is simply a mathematical function that multiplies each input by a number. And so when we are tuning this model, what we are essentially doing is that we are changing these numbers. Okay, so this was a model with only one neuron, a very simple model. When we put many, many neurons together in a network, we can create complex artificial models like ChatGPT. ChatGPT has over 170 billion tunable parameters. Now, let me give you some examples of networks. A network could be taking this input and biopsy slide, and then giving a prediction as to whether the cancer showed in the slide will spread or not. So this is a very, very important application of AI, where these predictions made are far superior than any prediction that can be made by a human. Another example is a network that gets as input some text. So this is a great getter quote, and then gives the word that most likely follows the text. So this is the basis of how models like ChatGPT work. Now you may say, okay, we know how neural networks work. They are inspired by biology, but they are not really intelligent. They are mathematical functions, after all. This is generally not true, however. Why? Because there may be more than one road to intelligence. The great analogy of this is flying. Birds, we know that planes are inspired by birds, right? But planes do not flap their wings like birds do. They use jet engines instead. So there may be more than one road to intelligence, and we not have to precisely mimic biology. Okay, so this was the risks of AI, the science of AI. I will not talk about the benefits of AI. So to do so, it is important to differentiate between two types of thinking that we humans do: System 1 thinking and System 2 thinking. So as Kahneman explains in his book, Thinking Fast and Slow, System 1 thinking is fast, automatic, and conscious. So think of when we are driving a car on an empty road. This is System 1 thinking. System 2 thinking is slow, it is effortful, it is conscious. As an example, think of solving a difficult multiplication problem. This is System 2 thinking. AI is expected to automate any task that requires System 1 thinking. So the applications that can be beneficial to society are endless. But just to mention two, if we can use AI to reduce the number of road fatalities and the number of cancer fatalities, this would be a huge win for AI and a huge win for humanity. In fact, arguably, AI forms the backbone of the next big revolution of society. So we all started off as hunter-gatherers, so hunting animals, searching for food. And then with the agricultural revolution, we solved the problem of searching for food. And following the agricultural revolution, with the industrial revolution, we solved the problem of laboring for food. So these were the two big revolutions of humanity. And following the industrial revolution, we created a lot of jobs that require mental instead of physical work. This goes because we free time from working in the fields. And now following this mental work that we created, AI and its revolution comes in to do the mental work for us. And who knows what comes next. So let me conclude this talk with the risks of AI. So you may have read in the news, or you may have heard prominent people talking about AI getting malicious and harming humanity. So I hope you will now understand that this cannot happen, at least as for now, simply because neural networks, the driving force of modern AI, is simply a mathematical function that does precisely what we tell it to do. Okay, so there's no danger in AI getting malicious anytime soon. It can't be used, however, maliciously by people. So AI will empower already existing crime, whether this is disinformation, fake news, whether this is online scams, autonomous weapon making, or hacking. So society needs to increase effort to catch up with this crime. And AI itself can help with this. To give you just one example, Facebook is using AI to fight fake news, which it does so successfully, where fake news are themselves generated by AI. Now, there are also risks that are concomitant to inherent limitations and widespread usage of AI. So let me explain this using an example. Assume we have a model that takes as input a loan application, and then it gives an output whether the loan application is accepted or not. So assume that the application is not accepted. An important information that the applicant needs to have is why the application was not accepted. However, AI cannot do this. This is what we mean by AI being a black box. We can look into the nodes to try to find information, but all we can see is numbers with no meaning. So AI is not explainable. Using the same example, because exactly a network is a big complex function, it is possible for a malicious adversary to manipulate the input so that it tricks the model into saying yes to a loan application that should be rejected. So this is what we mean by saying that AI is not robust. It can also be biased, say biased against women, if the data it was trained on are biased against women. And finally, AI will definitely cause a lot of job displacement. And say society is very important that it provides a safety net for the people that will be affected, and retrain them to new jobs that will probably be created by AI. Now, let me conclude this talk by saying that these are risks that can be mitigated. And to give just one example from my own work, in collaboration with Safe Intelligence, Imperial College London, and Boeing. We have put forward methods that can assess the safety and robustness of landing systems for autonomous aircraft and identify the conditions under which these systems can operate safely, but also identify the vulnerabilities which can then be mitigated. And with that, I would like to thank you for listening.
Thank you very much. Are there any questions from your end? And if so, it would be nice if you can use Slido to send these questions to us. With a topic like artificial intelligence, it's hard to raise a question that can be answered, or can be understood, because that's such a natural intelligence issue as well, a challenge. I'm impressed about what you said, and I'm looking forward to many, many speeches from your end to see what's going on over the next years. I think it will be most interesting.
Thank you all for listening.
Thank you. So, as far as I can see, no questions for this one. There's a chance to raise these more. Thank you again.
Thank you.
Thank you. Bye-bye.